So they had mentioned to us in the video that we just saw that it depends on the way that you slice your cone as to what type of a figure you're going to come up with. So if we take a double cone, one base up and one base down, and we slice it perfectly parallel to the base of that cone, that's what creates the circle. If we slice at a diagonal where we're still completely intersecting the cone, that's what creates our oval or our ellipse. If we slice at a diagonal but we don't, the slice that we get, the cross section we get, is not completely on the cone, we end up with like a part of it that's on the cone that creates a parabola, and then the other, what would be like the other half of our ellipse, is kind of up in the air. So we end up with a parabola. And then if we cut perpendicular to that base, then we'll create what almost looks like a parabola on the top and a parabola on the bottom. That's our hyperbola. Now, there are also something called degenerate conic sections. We don't spend a whole lot of time with those, but the idea of a degenerate conic section is just, let's say that I'm cutting perfectly perpendicular to the axis that's running through the center of these cones, or parallel to the bases, and I'm cutting a circle. If by chance I happen to cut at the one exact place where those two cones touch, I'm not going to get a circle, I'm just going to get a point. Now, we could argue that a point is a circle with a radius of 0, but that's the idea of a degenerate conic section. If I take the regular conic section and I degenerate it down to a smaller figure. So we could do the same thing with several other ways that we slice. Sometimes we'll create a line, sometimes we'll create intersecting lines. All of our conic sections come from the general second degree equation that you see listed there on page 696. So we're not going to use, for instance, for a parabola, you're not going to have an x squared and a y squared in the parabola, so you may not have a, b, c, d, e, and f for every one of these, but they all could come from that general second degree equation. They also mentioned to us a bold print term down here, a locus or a collection of points. You'll hear them referring to that in the video, that if we have a locus of points, all that they're talking about is a collection of points. So over on the top of page 697, they give us the definition of a parabola, and they tell me that a parabola is the set of all points, the collection of all points, the locus of all points, however you'd want to refer to it, that are equidistant from a fixed line, the directrix, and a fixed point not on that line, the focus. So the idea is, if I were to put a push pin right here and tie a piece of string to it, type of thing, I could stretch it to the focus and stretch it to the directrix. It would be the exact same distance going both places. Another way to think of it, as every single point on your parabola is going to be the same distance from that focus as it is from that line, that directrix. And of course the images there in the book are going to be drawn to scale, whereas ours are just rough sketches, so they won't always be drawn to scale. Some other things about our parabolas. I know we feel like we know everything that there is to know about parabolas. I mean, we have done factoring, completing the square quadratic formula to solve them. We've graphed them. We've shifted them, reflected them, all kinds of stuff already this year. But I don't think that we have seen that idea of the directrix or the focus. So that's what we want to add in here to our understanding of what we already know about parabolas. To begin with, our parabola is going to wrap around the focus, and it's going to run away from the directrix. It's going to open in the opposite direction of the directrix of that line. Also notice that sometimes our parabola will open up or down, and sometimes it'll open left or right. So we typically refer to that as a vertical axis or a horizontal axis. That goes back to the axis of symmetry. Remember, your axis of symmetry is that line you can draw down the middle of your parabola through your vertex. Your parabola can fold on top of itself. That's our axis of symmetry. So if that axis is vertical, then we're talking about something that's going to open up or down. If that axis is horizontal, then it's going to open left or right. Additionally, if it opens up or down, it's going to be in the form of y equals x squared. And if it's going to open left or right, it's going to be in the form of x equals y squared. Now, that makes sense that x and y are just switching places because this would reflect in the line y equals x like an inverse would. We still have the idea that any value subtracted from x is a horizontal shift and any value subtracted from y is a vertical shift, and that hk will be the vertex of our parabola. So none of that is new for us. So let's talk about this idea of the focus and the directrix. To do that, I'm going to need something called a p-value. If you'll notice, the coefficient that we have in front of the y to the first term, or down here the coefficient in front of the x to the first term, that coefficient, we usually look at that to determine if it opens up or down or left or right based on whether it's positive or negative. But that coefficient can be rewritten as 4p. In that case, p is going to be the distance from the vertex to the focus, and it is also the distance from the vertex to the directrix. And that's the same whether I'm working with a vertical axis or a horizontal axis. If p is positive, it's opening up, negative opening down, so that's the same thing that we had learned when our leading coefficient a was positive opens up, negative opens down. And similarly down here, when it's positive, it'll open to the right in the positive direction, and when it's negative, it'll open to the left in the negative direction. So to begin with, they give me some information about a parabola, and they ask me to come up with some additional information. For instance, this one, they give me the vertex and the focus, and they ask me for the directrix. So I'm going to take what I've got. I know my vertex is at 1, 3, and my focus is at 4, 3. So to begin with, which way is this opening? Up, down, left, right. Our vertex, or parabola, is going to wrap around our focus and run away from our directrix. So if it's starting here and it's got to wrap around my focus, which way is it going? To the right. So if this is opening to the right, I could say my directrix is going to have to be over here. And I can see the distance between my vertex and my focus is 3, so that means my p-value is going to have to be 3. So if I want to find my directrix, all I have to do is come right here to my vertex and back up 3. So if I'm at 1 and I back up 3, where would I be? At -2, right. So if I back up to -2 to draw my directrix, what's the equation of every vertical line? X equals or y equals? X equals. So we'll have x is equal to -2. Now, for your directrix, you do not want to say -2. -2 is a point. X equals -2 is a line. I'll take off if you do not put the x equals or the y equals with it, depending on whether you have a vertical axis or a horizontal axis. You do need the equation for your directrix, not just a singular value. All right, the second thing that they ask me to do here is, instead of just give one piece of information, they say if we give you the equation, we want you to give us all of the information. We want to know what's the focus, what's the vertex, what's the directrix, sketch a graph, give me the kitchen sink. They want to know everything. All right, so let's start with looking at our equation. Is this going to have a horizontal axis or a vertical axis? Looking at our equation, horizontal axis or vertical axis? Vertical, right. Because I've got x squared, but I've got y to the first. So when I have x squared but y to the first, that's vertical. If I have y squared but x to the first, then that's horizontal. So if I match that up, then I can find hk. Nothing different about this at all. Exact same way that we used to do it before. So what is h? -1. And what is k?
1.
+1. Because remember, it is the opposite of whatever that number is, because it's x minus h, so that's like opposite of h. So opposite of +1 gave us -1, and opposite of -1 gave us +1. All right, and then I can come over here and plot that vertex. We've got a vertex at -1, +1. Now, I can also look at this equation and notice that 4p is in the same place as -2. So if I set those equal to each other, if 4p is equal to -2, I can divide both sides by 4, and I'll get p equals -1/2. So since P is less than 0, what does that mean? Is it going to open up or down? Down, right, because when P is less than 0, then this opens down. So I have a pretty good idea of what my graph would look like. Now I just need my focus and my directrix. So if I start at my vertex, I'm going to go and have my parabola wrap around my focus. So that means the focus will be in here, and it's going to run away from the directrix or open away from the directrix. So that means my directrix will be up here. P is the distance from the vertex to the focus, and P is the distance from the vertex to the directrix. So if I start at -1, 1, and I go down 1/2, where am I? If I start at -1, 1, yeah, if I go down 1/2, then I'm going to be at -1, 1/2. So that's going to be my focus. If I start at +1 and I go up 1/2, where am I? 1.5, right. So my directrix is going to be at 1.5. And as we said, I want to give the equation of the line, not just the value. So I'll want to say y is equal to 1.5 or y is equal to 3/2. Now, not always will they give me my equation in standard form. Sometimes they'll give it to me in y is equal to ax squared plus bx plus c form. And in order for me to do what we've just done, I'll need to convert it into standard form. All right, how do I convert it into standard form? That goes back to completing the square. So it's been a little while since we've done that, so let's review back over that. When you're completing the square, your leading coefficient has to be a +1. So the first thing that I want to do is I want this -1/2 to be a +1. So I went through and multiplied the whole thing by a negative, and then I went through and multiplied the whole thing by 2. You could do that in one step instead of two separate ones. When I complete the square, I need to move the coefficient to the constant to the other side. So let's add that 1 to the other side. There it is right there. To complete the square, we take the coefficient of the middle term, 2, cut it in half, 1, square it, 1, and add that to both sides. So there's the 1 that we added to both sides. The whole purpose of completing the square is to create a perfect square. So x squared plus 2x plus 1, we just created the perfect square. That's x plus 1 squared. So I could leave it this way, but because I'm trying to match these formulas up here, where they've got the common factor out in front and then just y minus k in parentheses, then I want to do the same thing here. I want to take out that common factor of -2 and leave just my y minus k in parentheses. So if it had been given to me in this form, that's how I could transform it into the standard form. Now, I think it's a whole lot harder when they give us the equation and they ask us to come up with all of the information than when they give me the information and ask me to come up with the equation. Because if I'm coming up with the equation, I only need two things. I need the vertex and P, and I'm done. That's it. I don't need the focus, I don't need the directrix, I don't need a graph, I don't need any other information. I just need vertex and P, and I'm done. Okay, so let's look at this first one. For this first one, they told me I had a vertex of 2, 1, and I had a focus of 2, 4. So if I have to start at the vertex and I have to wrap around the focus, which way is this opening? Up. Why does that matter? Because I need to know which of these equations to use. So since it's opening up, then I have to use the vertical axis equation. So I'm going to copy that red equation down there. We said we need two things. We need the vertex, because that would fill in HK, and we need P, and we're done. We already had our vertex, right? They gave me HK, so let's plug that in. So 2 in for H, and 1 in for K. How do I find P? Count, yeah. Is the distance between what two things that we know? The vertex and the focus. Yes, the vertex and the focus. So if I find the distance between 2, 1 and 2, 4, that'll be my P value. So that distance is going to be 3. And because this opened up, I know that it has to be a +3. If it had opened down, it would have been a -3. So now let's come over and let's put 3 in the place of this P. So 4 times 3 will give us 12, and that's our equation. That's all we need. We only created the graph just to help us envision this. You don't have to create the graph if you don't need it. I look at another one of those. This time they give me the vertex is 0, 0, and the focus is 2, 0. So which way is this one opening? To the right, because we're going to start at our vertex and wrap around our focus. So do we want the vertical axis equation or the horizontal axis equation? Horizontal. So we'll copy that equation down here, and now all we need is the vertex and P, and we're done. So we were given our vertex. Let's plug that in. So 0 in for H and 0 in for K. And then we need P. Is P going to be positive or negative? Positive, because we're opening to the right. And it's going to be what value? 2, right, because the distance between 0 and 2 is 2. So we can come in here and put 2 in the place of that P, and so our equation would be y squared is equal to 8x. Now, in each of these two examples, they had given me the vertex. They might not always do that. Like, look at the next example. In the next example, they give me the focus and the directrix. What am I supposed to do with that? All right. If they give me the focus and the directrix, how can I find the vertex? Where is it in relation to those two things? In the middle of them, yeah. So all I have to do is just find like the midpoint halfway in between them. So I can still do that. So let's plot what we know. We have a focus at 2, 1 and a directrix at y is equal to 3. If I have to wrap around the focus and open away from the directrix, which way is this opening? Down. Yes. So if this is opening down, then I'll know which of these two equations I want to use, that I'm going to want to use the vertical one up here. And as you already told me, to find the vertex, all I need to do is find out what's in the middle of these guys. So if I was at 2, 1 for my focus, and I'm at 3 for my directrix, then my vertex is just going to be halfway in between them. Where is that? 2, 2. So that's going to be my vertex. So let's take that equation from it opening down with a vertical axis, and let's put in our vertex. So we'll put in 2 for H and 2 for K. Now we need P. Is P going to be positive or negative if I'm opening down? Negative, right? And what is the distance between either the vertex and the focus or the vertex and the directrix, whichever way you want to go? 1. So P then will be a -1. So let's put P in the place, -1 in the place of P in our equation, and we've got it.